So there is a lot to cover. Hope it's understandable. So there are two basic components when it comes to configuration management: the configuration itself and the application that is going to be configured. The application for the purpose of this demo is understood as a Helm chart template / configure, and the configuration is the values YAML used to template the chart. So it's pretty much basically Helm lingo, Helm primitives. So far, we are storing most of our configuration in Giants Farm installations repo, but it has its drawbacks. And as we were working, I mean Team Biscuit, were working on turning workload clusters into management clusters. We decided that what the current installations repo has to offer is not enough. So we decided to build everything from the ground up and replace installations repository with the new Giants Farm config repository, which is this thing right here. And you can see that we have 3 interesting directories here. The default, include, and installations directories. For now, I'll skip the include and let's see what's inside the default directory. So here we have config.yaml, more on that later, and apps directory in which we store per app configuration. As of right now, we have only AWS operator app configured here. Here we can see the default config map data and secret data configuration. Like, I won't go into the details. I want just to briefly cover the configuration. So we just covered the default one for the config map and the secret, and let's check overrides, which we have for each installation. So if we go here, for example, to Alpaca, there is a similar structure. Again, config YAML, but it's a patch now, and secret.yaml, which is new. Again, talk about it later. And the familiar apps directory where AWS operator installation specific values are stored. So if you click there, this again, config map values YAML patch, secret values YAML patch. Yeah, going back to the presentation. What's generated? Okay. So now we know that we store some shitty config somewhere, and what now? Now I'd like to show you how to quickly you can generate it yourself. To do so, we can use config controller generate command. First, you need to install config controller binary, which is quite easy. You just clone the repo and run make install. And then you run config controller generate, specifying app, config version, installation, and the name of the namespace of the config map and the secret you want to generate. The config version here can be either a major version range, like here in the example, it's v1, or branch name. Why? We'll talk about that later. And now let's look at 2 examples I have here. So here you can see that the generated Kubernetes resources metadata is basically the output of the command we've discussed and piped through YQ, and so all the data is removed. So you can see the metadata only. The things to note here are underlined with red lines. So you can see that I specified name Pavel and namespace demo, and I have config map and secret generate with that name and namespace. Yeah, so this is not super exciting. Now let's look at the little bit more interesting part. So now instead of removing the data, I just took the first 20 lines of the output of the same command, and you can see that it generated the config map values key in the config map data, and here are like kind of familiar values without the installations v1 prefix. Yeah, okay. So now that we know that we store some shitty config somewhere and that we can generate config map and a secret from that, and what now? Now I'd like to show that the config map and the secret are the building blocks for the values YAML used to template the apps chart release. So after being created in the cluster, config map and the secret generated by the config controller are linked to the app CR. And then app operator does its thing, and the generate config map data and the generate secret data are merged together to create values YAML, which is then used to template chart release behind the app, which is a known thing. Like, this is just how app operator works. But just for completeness, I wanted to mention this. So now let's have a look at this picture below. So on the left-hand side, you can see the generated config map we've seen before. And on the right-hand side, there is a values.yaml file from AWS operator repository. You can see that the data from the config map and the secret, which isn't shown here for the sake of simplicity. Yeah, so the data from the generated config map has one-to-one relationship with values.yaml on the right-hand side. So again, config map and secret are generated, their data is merged, and then data becomes the values used to template apps chart and apps chart release. Okay, there are a couple of tadas coming with this approach. So we don't have installations v1 prefix anymore. We start key names with lower letter. The default values are defined in values.yaml instead of the configuration repository, because so far the reality was that only the stuff that wasn't overwritten was in values.yaml, and everything else was living under installations v1. There is no installation v1 means helm/AWS operator/CI directory is gone. And I believe all of that makes our apps more streamlined and community friendly. Okay, so now that we know that we store some shitty config somewhere, and that we can generate config map and a secret from it, and that config map and the secret data combined are the values used to template the chart, and what now? Now I'd like to show you how to make changes in the Giants from config repository. So I'll focus on application configuration specifically and not on adding a new installation. But after that, like, I think adding a new installation should be rather straightforward. For now, let's forget all about everything I've said about config maps and secrets and how they are used, because that's a different part. Now we focus on how the config map and secrets are generated. Okay, so I'm in the Giants from config repo. You can see it here. And let's go to the default config map for AWS operator. So I wiped it out completely, so we can start fresh. I also wiped out completely a config map override for GOS. So if we go to GOS here, to apps, AWS operator config map, it's also empty. You can see it side by side. So let's start with a simple example. So I will configure AWS operator default to have those two keys. Do one thing. Let's have those two keys, and let's generate config map and secret from it. So what I do is I generate app AWS operator for config version demo, because that's my branch name. For installation goes the secret config map and the secret name and namespace or power demo, like in the examples in the slides, and I extract data from both. So let's run it. So we should see a default A and B default B in the config map. And yeah, so we have it here. And if you wonder what's that, then this is just empty secret because I wiped it out as well. Okay, so we set something default that's simple and that's probably not super exciting. So let's do an override. So we go to installations, goes. We have nothing here because I'm like by default, when you create a new installations, you should have only those two files, config.yaml and secret.yaml. Again, we will get there later. So let's create apps AWS operator directory here. How do I do this? I think it's like this. Goes to AWS operator. Okay. Refresh. I have apps AWS operator that's empty. That's okay. And now let's edit the overrides just on the bottom, like AWS operator config values YAML patch. Refresh this. It's here. It's here. And let's do an override. So I will override the value A with goals A. So you compare, have A default A and the override. So my expectations would be to see A, goals A, and B default B. Right. So let's push this again. And try to generate. Yeah, so we see A goes A, B default B. So that's how overrides work. Now, config map values are templated with config.yaml. So that's why we have this file here. And here are some basic values that are used between apps in the same installations and also between installations. So this is the default config.yaml. So as I said, we can use the values to template the config map here. Config map here. So let's template something like, and you can see that here we have, for example, registry domain. So let's use that and template this. So in the default YAML, I will create the default key and then the domain and set it to registry domain. So once again, push it and generate it. By the way, my expectation here would be to see here Docker IO, because this is what I have here on the left-hand side. Let's see. Yeah, it's like the default Docker.io. Yeah, but values from default config can be also used in to template installation-specific values too. So if we go to go specific config map file for AWS operator, let's see what's the config that is in the default, and we configure mirrors here, for example. So add a ghost key and add mirrors, and which are templated from the default config. So it should be here like a list of, sorry, giantsform.azure cr.io. Let me again push that. And generate it. So my expectation here would be to see what I think this transform is your cr.io, right? Because it's the same thing that we have on the left. Let's see. Yeah, it's here. So we have everything merged, the default domain, ghost mirrors, So this is like a typical, like for Chinese installations, we would override mirrors. So that's why we do it like this. Yeah. So the next thing to mention is that the config YAML can be patched for installation. This is useful in situations where the value is usually the same, but changes in some installations. Like I mentioned, registry mirrors will change for installations in AWS China. So let's patch registry mirrors for Ghost to see how it works. So, and I'll close that one. And let's open config.yaml patch for Gauss. And you can see like some stuff is here that is not in the default because it's installation specific. But we have also registry mirrors. So I will overwrite registry mirrors and set it to Gauss.io. And let's push it. Yeah, and now my expectation would be to see here now Gauss.io instead of giantswarm.azure.cr.io because we just overwrote it. And let's see if it's true. Yes, it's true. Great. So far, so good. Then we had the include directory, which is special. As I said, we talk about that later, and now is the time. And include directory function is to allow us to include big chunks of semi-static YAML. Good examples are AWS instance types. So like here, so this is a huge chunk, and we don't want this to be in the default config map because that would obscure the thing. So instead, we can include that. So for like in here, we have I didn't show the include because I override this. Yeah, but let's check an example. So I create a lorem ipsum file in include directory. Let's write that. So we have lorem ipsum.yaml.template, and I will add a lot here. And let's include this. We can include this either in the default config map or the config map specific to Gauss, but the usual approach is to include this in the default. So now we should have the same with a huge chunk of lorem ipsum text in it at the end. So let's generate that. Yeah. So we have all we had so far, plus this lorem ipsum thing we have in our include, right? So the lorem ipsum key, yeah. So that are basically the let's say features of config repository. On top of that, we added speak support, which should be known if you are advanced Helm user. So you basically have masterminds speak functions. So things like lower, functions like lower, and all the stuff that is in this website is available in the templates. That also allows us to nest includes because we have indent and stuff. So now we can have nested lorem ipsum instead of top level one. And to make it even more fun, I will also include this in in Gauss AWS operator config map, but under the Gauss key. So we have them both here. So Gauss lorem will be lorem ipsum text. But maybe for the sake of simplicity, I will just remove a bunch of stuff from here because, and also I'd like to show that what you include is this file name ~dot and not the key here. So let's remove that key and change the YAML, for example, to this. No idea what that means, but probably something stupid by now. Yeah, and let's push it. And regenerate it. So now it's getting weird. So it should see Gauss, lorem, and those keys are specified and nested. And those keys are specified in lorem. So we have Gauss, lorem, and nested lorem, right? So all of that works. Yeah. So we showed how the include works, and now what I'd like to show, is that this installation specific configuration, which I touched briefly. So while you're closing this, where are you? Oh yeah, installations, Gauss, and installation specific configuration. So here we have the values that we don't have in the default one, because they don't make sense. Like the base domain is specific to installations, code name is specific to installation, customer as well. Like everything here is specific to installation. Even those registry mirrors, because we want to use Gauss IO, and then you can use it basically like this, right? Which I don't think is a mystery right now. So if I want to include code name somewhere, I can just do this, and then it will render Gauss because it's for Gauss. Well, I don't know if we need to push it and check it, but let's do. Yeah. So that's so far for the Giants from config repo. Like, is it clear? Yeah, cool. So, do we have this coding Gauss? Yes, we do. So now we want a little bit creative, so I'll clean all of that. What about this? What about this? And I'll talk a little bit about secrets. Where am I? Let's check if it's nice and clean as well. Okay, so secrets are different from the config mouse because we don't have a global secret.yaml file. Similar to cluster.yaml file, we have only installation-specific secret.yaml files. Yeah, and there is a reason for that. So something smart said that we don't have shared secrets. It just happens that our secrets have the same values. Unfortunately, I cannot take credit for that one. So that's the quote. So the secrets are installation specific because of that. And that means they are encrypted and they are encrypted by the installations vault. This means that if by accident a secret from a different installation is templated, it won't be decrypted because the installation vault won't know how to decrypt a secret from another installation, which is very nice. This also means that we don't have a shared DPG secret, which is very nice. But this also means that we had to rework obfusctl encrypt secret, and now we have obfusctl secret decrypt, which I'm not sure how nice it is, but it is like it is right now, and eventually we should get rid of obfusctl verb secrets commands and have only obfusctl secret verb commands. So yeah, let's give it a try and create a secret for AWS operator, a default one, right? So we have default apps AWS operator secret values YAML template, and it's empty. So let's add something here like, I don't know, ops genie token and push it. I hope everything is clear. Yeah, config map is clear. Secret is clear. Yeah, let's see what's generated. Yeah, so it generates nothing because we have nothing templated. To be honest, it should fail. So it will one day. So let's set it to some value. So as I said, we don't have global secrets. We have installation-specific secrets encrypted by the installation-specific vault. So I need to somehow set it. So I will edit TMP secret and set some ops genie token here, and then I will encrypt this, right? So as I said, obfusctl secret encrypt, not encrypt secret. Input is TMP secret. Output is installations code secret.yaml, and I have to add an installation as an argument because the command has to know which vault to use to encrypt the secret. So now I should have so I should have some stuff here, which is like vault v1 has a vault v1 prefix. This is because we are using transit key backend in vault to encrypt that stuff. And now I push it again. And since this was encrypted is this, I would expect to see ops genie token, secret ops genie token in the secret. In what form? Yeah, it should be ops genie token and something like this, right? So let's generate it and see. Yes, ops genie token, secret ops genie token. So this is how you configure secrets. Like now let's do similar thing for the override. Oh, maybe one thing I can show is that if you try to show the secret, but if you choose a different installation, like I choose Gorilla, I could literally choose anything else than Ghost, then it will fail, saying that it's unable to decrypt because this vault is unable to decrypt this secret. So if I specify Ghost instead, we should see secret ops genie token. So that's a proof that if you do something wrong and put a secret from one installation in a different installation, everything's okay because it's not decryptable there. So now let's create application-specific secret. Like create a GitHub token and go to ghost secret, and no, this is not where I want to be. Is it there? Oh, we don't have the file. Fine. So what's the file name here? Secret values.yaml.batch. Let's create that one. What I'd like to have here is GitHub token and template git secret YAML. We want to have GitHub token here. So we push it. So what I expect to see here is to have Opsgenie token and GitHub token merged together. So this is just to show that if there is a secret that is specific to an installation, because I don't know, provider, whatever, then you can specify this on the installation level, and that also works. Did something bad here. Yeah, somehow I forgot to write my notes, so it doesn't work, but it should. Sorry. Yeah, so that doesn't work. Let's switch to presentation, but it's more or less how this thing is supposed to be configured. So again, I'm switching to my presentation window. If you don't see it, then let me know. There are a few rules. Sorry, there are a few rules to follow when editing Giants from config repository. So starting with the rule number 1, keep config.yaml minimal. Values here should be added only if they are used by multiple apps in multiple installations. We should keep installation specific config.yaml.patch minimal as well. Values here should be added only if they are used by multiple apps in a single installation. And finally, we should keep the defaults in the application repository, the values.yaml, and not in giantsform/config, unless that doesn't make sense from an open source user standpoint. For example, like why anyone in the community would you like to install app with giantsform employees SSH keys list set? So in that scenario, this SSH keys list should go to giantsform config. The good news is that we also have smart people in the company, and Kubo is working on linter to help you with obeying those rules. As an interesting fact, the first test run of the linter showed 129 errors, and all the configuration was written by the inventors of those rules. So the linter is pretty much welcome. I have a link for the next slide. How to use. Yes, we want how to use it. Okay, so now we know that we start some shitty config somewhere and that we can generate a config map and a secret from it. We know how they are generated, and we also know that config map and the secret data combined together are the values used to template the chart. And what now? Now I'd like to show you how to use this thing in real life. So this is fortunately quite simple. After you have your configuration ready, you specify config.transform.io/version annotation in chart.yaml in your application repository. So like here. You release your application with that annotation. That's it. Release operator and JAWSum do their job, and config map and secrets for the specified configuration version are generated and linked to the app CR. Boom. Right. And now I should finally explain why we use the major version range. Because we know pretty much everything we need to know to go ahead and configure our applications. This is just a last bit I should mention. So here are some version backward compatibility rules we came up with while designing this transform config repository structure. So we should do the patch bump if configuration value changes, but the configuration key doesn't. For example, when we change the network ranges for whitelisting or adding or removing an instance type for AWS. We should do the minor bump if a new configuration key and value is added. This is usually after adding a new feature to the app, and then you want new config. And we should do the major bump if the configuration key is renamed or removed. This is the case when we have a new version of an app and the configuration changes for that version in a breaking way. So let's say we start supporting multiple AZs, and we'd like to change configuration key from availability zone taking a string to availability zones taking a list of string. That would be a major bump. Yeah, and that hopefully explains why we decided to go with major version ranges. The main motivation here was to allow changing the values freely and not carry legacy configuration keys between application versions. Okay. I mentioned a couple of times already that we also allow branch names to be specified as a configuration version. This is so you can test your configuration changes before making a release in Transform config. I also should mention that those version rules should appear in the project README. So if you want to refresh your memory, you can go there and reread that. And yeah, that's all, folks. Now, I hope we really know how to go ahead and configure our applications. But please keep in mind that this is still all early stage and feedback is welcome. Also, contributions are welcome if you feel like migrating your app now. We also don't support configuring unique apps yet, and we migrated only AWS operator. So that's it. Thank you, everybody. And if you have any questions to ask, or feel free to reach out to Biscup.
I have one question though.
Okay.
Understand how this works, and it's pretty neat. I really like it, but I can see myself trying to debug something after being paged. And so, is there any like a flow chart of how those values got generated?
Yes, there is.
Okay.
And yeah, we probably will link there in a repo. There are a couple of flowcharts. Like there was a previous demo where we pitched the idea before having any implementation in place, and this is described by Kuba there, and slides are available.
It's literally the thing I said today during the sync. Like, do we want to, at least in CLI, like print some flow? How do we take different configs and construct?
Yeah, I thought about like reusing those charts again, but I decided against it because I thought I will try to do it in a different way. So because you can watch this demo again, it's pretty up to date. Not many things has changed since then. and then you can watch this and you can try to digest this from 2 angles.
And another question, if I want to test my app locally using Kind, for instance, now it's pretty easy because I can just run this CLI, generate the config map and the secret, create those in Kind, and I'm good to
Yeah,
go.
but you also would have to create app and link them.
Right.
Okay, yeah, but this is designed so you can do config controller generate and pipe it through kubectl apply, and then you should have those in your cluster. So that is really convenient.
Okay, because yeah, we have some integration tests that install some app, for instance, the admission controller app, and we are installing those as apps in Kind using app test. So it would be cool to have the configuration using this config controller, and I think it could be done.
Yeah, that's great. Great to hear that. Then I stop here.